This as the philosophy behind the STTP. I, Professor Deepa R, on behalf of the Department of CSC, SRM Institute of Technology, Vadapalli campus, welcomes you all to the short-term training program on big data, machine learning, and deep learning, the paradigm shift. Through this STTP, we aim to provide you with multiple facets of how availability of data can be earned and utilized. With the humongous of data at our disposal, the solution to problem has become easy as there is a lot of background information available with us now. In this STTP, we have tried to bring practicing data scientists and machine learning experts, both from industry and academia, to share their experience and expertise in this domain. To organize an event of this magnitude is always a Herculean task, and our event coordinators started to roll on wheels since the program schedule was announced. They made sure everything was arranged. They stand as our pillars for the event. May I now request Dr. Meenakshi S. Arya, Professor, to throw some lights on the key points of the STTP. Please, ma'am.
Good morning, everyone. Thank you, Deepa, for introducing the STTP. It gives me immense pleasure to see that we have participants from all across the country. And as Deepa has already brought it out, that our aim through this STTP is actually to give you divergent perspectives on how this paradigm shift, which started with the availability of too much of data, the growth of statistical analysis for that data, which incorporated machine learning, and then finally, the urge to dig deeper into these machine learning algorithms so that we can emulate or simulate things the way our human brain works. So the paradigm shift that we have seen in the past 1 decade is definitely going to go a long way with us. We have speakers from all backgrounds, as has been shared with you already, so as to share their knowledge and share their experiences. You can see that the speakers are a mix of people from industry as well as academia. And they have been pioneer in doing some breakthrough research as well as being actively involved in academic discussions on the topics that we have chosen. Not taking much of your time and thanking you all once again. I, on behalf of Department of Computer Science and Engineering, Vadapalli campus, would like to welcome you all to this 5 days of journey on the paradigm shift from big data to machine learning and deep learning. I hope the incoming 5 days have a lot to teach you, and you have a lot to learn and gain from the benefit of this resource person that we have. Also, I'm pretty happy to announce or to share with you that we could get the sponsorship, the technical sponsorship of NVIDIA. And on day 2, we have a special session by Mr. Unni Krishnan, who heads the developer ecosystem and who's connected with through NVIDIA with the academia as well. So NVIDIA has been kind enough to consent to provide their teaching kits, which involves the teaching kits for deep learning, for machine learning, to all the participants on successful completion of the course. We would expect you all to maintain at least 75% attendance, give feedback after every session, and also attempt the test, which is scheduled on the day 5, that is 18th December, after all the sessions get over. I'm looking forward to your active participation as much as the resource person are willing to share their knowledge and expertise with you. I wish you all 5 days of happy learning, and once again, welcome to the STTP. I hand over back to Deepa.
Thank you, ma'am. Now I would like to invite Dr.
So a very pleasant morning to one and all present here. So on behalf of SRMIST Vadapalani campus, I would like to thank Dr. Kanchana from Assistant College of Engineering, who has accepted our invitation and consented to be our speaker for this STTP on big data, machine learning, and deep learning, the paradigm shift. I take this opportunity to express my sincere thanks to our Dean, Dr. K. Durevelu, HOD CSE, Dr. S. Prasanna Devi, without whose support, this STTP would have been just a dream. Last but not the least, I would like to welcome all our participants and audience for the day who has shown keen interest in registering for this event. So your active participation and presence has enlivened the start of this day. So welcome all. So thank you on behalf of the Department of Computer Science and Engineering, SRM IST Vadapalani campus. Thank you.
Thank you, ma'am. With great pressure, I would like to introduce our first resource person of the day, Dr. Kanchana R, for the session on Introduction to Big Data Analytics, Machine Learning, and Deep Learning. Dr. Kanchana R, Associate Professor, Department of CSC, SSN College of Engineering, Chennai. She has completed her PhD from NI University. She has done her master's in CSC from NIT Trichy, and she pursued her bachelor's in CSC from Tyagaraja College of Engineering, Madurai. Dr. Kanchana R has 2 years of industrial work experience. Ma'am has served in NIT Trichy for 16 years, and then she has been with SSN till date. She has around 14 years of experience in SSN. Ma'am has published over 37 papers in international journal. She is currently working on a research project on immunization data analytics funded by BIRAC, DBT, COIL in collaboration with IIIT UNA, HP. She has completed several consultancy projects from industries such as Caterpillar, ACI Automation, and many more. She has awarded as SSN Best Faculty in the year of 2016. It's such an honor for us to have you today, ma'am. Ma'am, the session is yours.
Thank you, Dr. Deepa. Thank you for the introduction.
Thank you, ma'am.
And a very good morning for all the participants. As a first session of this STTP, I'm going to introduce what is big data and the big data technologies. Participants, if you have any suggestions or observations or questions, you are free to ask me, or you can type in the chat. So let me share my presentation. Is my audio and video clear to all of you? Can any one of you respond?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Ma'am, it is clear, ma'am.
Okay. So what is big data? You must all be knowing, but we are living in data age. As per the statistics, in 2000 up to 2016, 0.18 zettabytes of data is involved in this digital universe. Zettabytes is equivalent to 10 power 21 bytes, which is 1000 exabytes, or 1 million petabytes, or 1 billion terabytes. Terabytes, of course, everyone must be knowing. And in 2011, it increased by 10%, that is 1.8 zettabytes. And now, and it keeps increasing exponentially. And it is almost 20 times of that, that is 36 zettabytes of data, which constitute the digital universe. That means one hard disk drive for every citizen, or sorry, every person. So the data is too voluminous and it does not fit into any traditional structures. So we must think of, and also the data is moving fast, as you know, in social media. For example, in YouTube, we have 300 hours of videos, right? And the data is too voluminous, and there are lots of other characteristics I'm going to discuss shortly. We must be finding out new ways and techniques to process such a big data so that we gain some insight or value from this. So who is generating the big data? So in Facebook, as I told you, 300 hours of videos to almost 3.9 trillion photos were uploaded, and by 2020, 6 trillion photos, trillion. So you can understand. So we have lots of scientific instruments which are generating the data, and we have mobile traffic has become so huge. Like one statistics says 6.2 exabytes of data are exchanged. It is as per 2016, which is 6.2 billion gigabytes. So you can understand 6.2 billion gigabytes. So this, and nowadays we have smart city and lot of IoT based applications. So the sensors around us, every individual is having a mobile phone which has got lots of sensors. So a lot of data is being sensed. So the old model was companies were generating data and all the others were consuming that data. But now the model has changed. Everyone is generating data. As I said, the mobile is having lot sensors and it's capturing lot of data. So everyone is generating data through social media, our mobile phone, etc. And all of us are also consuming data. So the model has changed, which is the reason for the huge voluminous data. So whenever we say big data, that big we may assume or associate with volume, but it is not only that. It has lot of other facets, other dimensions. So the second dimension is velocity. So the data is flowing at a faster rate. Whether it is batch process or streams in real time or near real time, the data is like your Twitter feeds. Data is generated in at a very high speed. So if you are not capturing that stream, analyzing it and take some decision in time, you are going to miss your business. See, nowadays you must be knowing, whenever, for example, when we reach a mall, based on our past transactions or purchase history, whatever products we are interested in, they are analyzing, and immediately there is a suggestion in the form of SMS saying that that particular stores is available. Say, for example, I bought a book last week. Then there is a bookstore here and the kind of books available there. And if I visit that bookstore, I may be getting 10% discount. This kind of SMS will reach me as soon as I enter a mall. So if you are not giving the message or promotion at the right time, and that is not correct, or that is not promoting your business. It is much more sensitive in case of healthcare applications. So missing decision or late decision is not useful. So we need to consider this velocity dimension of big data. And variety, the type of the data is not structured as we have in traditional DBMS, rows and columns. It is unstructured. So it has, as you see, we have audio messages, video messages, text messages, and it is semi-structured like emails, logs. So there's a variety of data. The next is veracity. Veracity concerns the trustworthiness of the data. And what is the authenticity of the data? You may be having lot of data. If it is not trustworthy, then it is not useful. The next dimension is variability, which is concerned about data consistency. So the data, when it is collected, because that it can be unstructured and semi-structured, the same data may be not consistent in many when it is available in many places, and the interpretation may also vary. The same data, when it is available in one context, or the meaning is in one way, in another context it may differ. And changing models. So with big data, this is very important to this veracity and variability. The data must be the data quality, that's of major concern. So whether it is consistent, whether it is trustworthy. Viscosity refers to the relative timing, that is when the actual event occurs and when it is available in the system. So that's a lag time relative to the event. So that means a lot for us. In case of IoT applications, you need to sense the data periodically at the given point of time. Healthcare applications. So you cannot describe the data or process the data in much later point of time. So next is volatility dimension, how long the data will be stored. So, once the data is analyzed, we may no longer need the data. Sometimes we may require the data for some more time. So how long the data can be available? Visualization. So because of the volume of data and variety of data and velocity of data, you need to represent the data in a particular way which is easy to understand. So you need to visualize the different in different ways. For that, for the data to be visualized in different ways, the data must be represented suitably. So the next dimension is value. Value is whatever data you are storing, how do you derive value from the data? Value means in order to why are we interested in big data? Because we need to analyze the big data and derive some useful information which is useful in making a decision. So in addition to the volume, big caters to all these characteristics. Big means not only volume. All these dimensions are available. So how do we manage big data? The life cycle is, it starts with capturing the big data. How do we capture? How do we acquire big data for various applications, whether it is image or video or audio, whatever it is, how are we going to acquire? So once we acquire the big data, inspect its quality and how far it is going to be useful in a particular application, inspect that, analyze. And there could be, you see, for example, if you take image, definitely based on the method of acquisition, noise may be present or it may not be clear. So in order to make it suitable for our application, we have to clean or pre-process. And then in order to make it a standard, we need to transform. Like we can standardize the format of date. Date may be gotten in a particular form, but we can standardize it to make it in a particular form. Similarly, whether it is a audio, video, a particular format, a particular resolution, whatever it is. So standardize the data by transforming it. And then store. It's a big thing. So how are we going to store such a huge data? And once we store it, how are we going to access, search, index, all that? Then how do we model based on our application, so that once the learning model is available, how are we going to analyze? Next, the analyzed data needs to be visualized. You cannot present the data in the form of a table. If it is small, some 100 records or 100 images, you may visualize it in the form of graph. So graph is not adequate here. Tabular column is not adequate here. So we need more techniques to visualize the data so that we can discover some useful information from these big data and take a decision which will improve our business or our application. So the big data analytics refers to analyzing the data and communication, that is the decision making. How are we taking the correct decision by analyzing the data? So it needs definitely parallel and distributed processing. So you can see in this graph how the data storage is growing from 2005 to 2015. So after certain time, the growth is exponential. You can observe that. So in 2015 itself, it is 8 millions of petabytes. Petabyte is 1024 terabytes. So there are lots of challenges in managing this big data. You can see one analysis says 30% of the efforts spent in developing the software and technology. So lack of software and technology caters to 30%. Analytic skills, it's equally challenging. It's nearly 30%. The others are okay, minor. So we need to, this indicates we need to still develop lots of techniques and methods. The available techniques needs to be improved further to manage the data of today's volume. So the big data is not just about the size, but we need to find an insight from complex, that is a variety, noisy, heterogeneous and voluminous data. and we need to answer the questions which were not answered previously by following these techniques. So in order to carry out this or solve this challenge, it is not possible to depend on a single or individual computer. And it is very expensive to build reliability into every application. And fault tolerance is another challenge, because failures are not unexpected, it is always expected. So the solution is we need a large cluster of computers, which is a reliable, fault tolerant, and efficient. And most importantly, it should be open source. That is the requirement. So the clustered computing is a new paradigm. It has three important advantages. Resource pooling, where we are able to pool all the three resources like storage, memory, and CPU. High availability. So clustered computing offers fault tolerance. Whenever there is a failure, it is transparent to the users. So it is always available. And scalability, clusters or clustered computing makes it very easy to scale horizontally by adding more machines. As you need more machines, you can simply add. When there is a failure, automatically another machine will take control without the intervention of the user. And also the resource management. The resources are managed in the background automatically so that the services are offered seamlessly. Towards that, Hadoop is a software framework. It is from Apache. It is used for storing and processing big data in a distributed manner on large clusters of commodity hardware. So it is written in Java and runs on almost all platforms, and it supports commodity hardware, no special hardware. So in order to understand the difference between cluster and ordinary parallel processing or distributed processing, take this small example of banking application. So you have 4 databases here. Assume one is used for credit card, second one debit card, third for insurance details, fourth one is for storing the loan details, and all are stored in a data warehouse. And we can mine the data and do some analytics over the data. Assume that in 2 days, these 4 databases generate 1 TB of data. And there are 3 people who are analyzing this data. So here it is very difficult to analyze 1 TB of data every 2 days. And also see here, this is the periodicity. So one simple solution using our parallel and distributed processing concepts, divide the data, 1 TB of data into 4 parts of 250 GB each, and store it in 4 different servers. And whatever analytics or the program you want to run over the data, you run the program in parallel on these data. So the program is same, the logic is same, but you are applying the logic or executing the logic on different data. And then once the processing is over, you transfer or copy the data back into the server. So this is distribution, and the program is running parallelly on the data. But here the problem is transferring the data, 1 TB of data in all these 4 as to 250 GB, and then after processing, we have to transfer back to the data warehouse. So the network handling is a problem, and it takes huge time, like something like 12 hours. So we have in laptop, simple laptop, it's a very traditional system. It's a sequential process. We manage this with different drives. That's very simple, leave that. So just look at this Google file system. They offer a distributed storage, drive 1, 2, 3. So wherever is the code, the data will move. The logic is available, and the data from here will get, the logic will execute on this data first, and logic will execute on the second, third. So the programming logic is applied in sequence over different sets of data. This is what was proposed by Google file system. But sorry, but this is also a failure because the programming logic that applies on different data, it is in sequence. So we want that to be in distributed manner. So the solution is map reduce. So which is a distributed processing engine. Instead of bringing the data to the location of code, copy the program into the data location. That is the concept here. You copy the program, whatever application or logic you want to apply over the data, copy that to the location of the data without bringing the data here. But as you know, it is costly. Fault tolerance, all that is not available. So we have one more nudge distributed file system where we have a very good fault tolerance. If any server breaks, they use data mirroring. So now these two concepts are combined in Hadoop. Hadoop is a distributed cluster computing engine. So the storage part of the system is HDFS, Hadoop distributed file system. And the processing engine is called MapReduce. So it has the advantages of both Google file system and Nudge distributed file system. We can see here, there are two parts. This is HDFS, a storage part, and the processing part is MapReduce. So it provides massive storage for any kind of data. And processing power is too good. So limitlessly concurrent tasks and jobs can be handled by Hadoop. So this is the Hadoop ecosystem. So you can see HDFS here. It is used for storage. And the resources are managed by Yarn. In the first version of Hadoop, Yarn was not available, but in the second version, Yarn came into picture, which automatically handles all the resources, memory, storage, CPU. See here, this is Flume. Flume is available to represent unstructured and semi-structured data in HDFS. And Scoop enables storing structured data in HDFS. You can see here, this is MapReduce. I told you this processing engine is available. So we have Hive and Drill, which are used as SQL on Hadoop. Hive offers a lot of drilling, pivoting operations, and it is used for setting up the data warehouse. Hello.
Yes, ma'am. Please go ahead, ma'am.
Okay.
I'll just mute all the participants.
Okay. So we have Mahout. This is very important for in the, it is used. It is offering a set of machine learning libraries. So we also have with the Spark a data flow engine, which is in memory. I'm going to talk about Spark later. So in contrast to Hadoop, Spark is also from Apache, but it uses in memory. So I will throw light more on Spark later. So Spark ML library is also available. And we have for streamed data, we have Kafka streaming, Kafka, and also Storm. Both allow streams, processing of streamed data. And we have a scripting language, Pig, very useful language. We can either use Pig scripting or Java to write MapReduce programs. This is HBase. HBase is equivalent to our RDBMS, right? So in traditional DBMS, we use rows and columns, but that is not adequate for handling big data, which supports variety of data. So we have a whole lot of no SQL. No is not adequate. So it is lot of technologies are available. So a columnar data model is HBase. We have Solar, that is SOLR, and Lucene, which is used for searching the big data and indexing the data. And we have Zookeeper, another important tool. Zookeeper is used for managing the resources, and for coordination we have Ambari. And scheduling of tasks or jobs, we have Woozy. So you must have seen this Apache's ecosystem is offering huge set of technologies and tools in the entire life cycle of managing big data. So this HDFS is a very large distributed file system that can support something in the order of 10,000 nodes, 100 million files, 10 petabytes of storage. Very important contribution here is it assumes commodity hardware. It does not need, see, parallel processing, you need a special hardware. So here it does not require any special hardware. Whatever desktop or laptop you have, it can become a part of the cluster. And here, in order to promote fault tolerance, we have data replication. By default, any file is replicated 3 times. 3 is the default replication factor. And the failures are detected automatically and it is recovered automatically in the background. And it is optimized for batch processing because the data locations are exposed so that the computations or logic can move to the location of the data. That is the major advantage. These are the major advantages of shifting from a traditional distributed system to a clustered system. And it provides very high aggregate bandwidth. So aggregation of data is very useful, and it's a basic requirement for analyzing the data. So we have two kinds of nodes, name node and a data node. There is one name node and a set of data nodes. Name node is a master daemon, whereas data nodes are slave daemons. This name node manages these data nodes, and name node keeps track of metadata, where the data is stored, what are the data files are actually segregated into blocks. So name node keeps track of which block of which file is stored in which data node, and what is the size of each file, and what is the permission rights, etc. All this metadata about data is managed and stored by name node. And this name node retrieves a heartbeat periodically every 3 seconds, or that is configurable. Periodically, it receives a heartbeat from data node and also the block report, how many blocks are available, size of the block, etc. from each node, from each data node. And if there is a failure in getting heartbeat, immediately for any read or write request, it responds with another copy or replica in some other node. And there is a secondary name node. This is to avoid single point failure. So there is one name node. If that fails, then it is not possible to retrieve data from these data nodes. So there is a secondary name node. If there is a failure in name node, secondary name node will immediately takes the control over and manages the data nodes. So this is the architecture. Name node having the metadata, data nodes having the actual data, and the client can write and read the data. And you can see here, there are 3 nodes in rack 1 and some nodes in rack 2. And see, there is a replication. So we can have replication of data blocks in the same node, so that if there is a problem in retrieving that particular block from another block, we can retrieve it. Or if the data node fails, the replica or copy may be available in another node. If the node fails, we can retrieve from the alternate node. But if there is a failure in the rack itself, so none of the nodes in the rack can be used. In that case, a replica kept in another rack will be useful. So the replication can be in the same block, same node, or in a different node, or in a different rack. So based on the application, these are all configurable, and I'm only telling you the possibility. Depending on the application and requirement, this can be configured. How many copies and where to keep the replica and configure. And in case of failures, it is taken care of automatically load balancing, resource pooling, CPU pooling, everything is taken care of automatically in the background. About MapReduce. MapReduce provides the logic. So it has map and reduce. It is actually software framework. Once the input data is given, it has lot of logics, mapper logics applied on the input, and then they are combined using reduce logic to create the output. Before creating the actual output, there is one process here which will apply some summarization or uh, some aggregation operation after reduction, or some indexing or some sorting, whatever it is. So to derive an analogy of how MapReduce is working, let us consider a cook preparing the some dish, right? By picking up things from food shelf, right? So it can be analogous to a CPU. The processing machine is equivalent to a cook, and the food shelf where the items are kept, the resources, here we have a storage. So if the orders are taken manually per hour, if there are only 2 orders, this setup is more than enough. But if there are 10 orders per hour and the order is taken online, then this setup is not going to be useful. Here this is equivalent to getting the data in social media. So in which case RDBMS is not useful to handle that load data. So because the food shelf is because in the previous one, because one cook cannot handle 10 orders per hour, you just increase the cooks. But that does not uh, satisfy our expectation, because there is only one food shelf. In our case, there is only one storage, but processing machines are many, but still the bottleneck is the single storage. So the solution is something like this. So we identify the different tasks of the job. So in preparing the dish, we identify 2 tasks like cooking the meat and cooking the sauce. So we have multiple persons taking care of cooking the meat and cooking the sauce, and each is provided a food shelf storage, so that these 4 are preparing the food simultaneously, and the resources are also distributed. And see here, he is the new person appointed to assemble these 2, sauce and meat. So whoever has finished cooking the meat will transfer here. Whoever has finished cooking the sauce will transfer here. That will be assembled, aggregated to create the final order. Hope it is very clear why we go to clustered computing. Okay. So it is failure tolerant. More cooks can be added, like that more machines can be added to improve performance or to increase storage. We can add simply more machines, and the configuration, everything will be taken care of. And scalability is not a problem here, and it is industry standard. So distributed applications can be built on top of HDFS. and it is designed to process large data sets with write once, read many semantics. And it is not suitable for low latency access. It is anyway, we are going to use this for big data. So HDFS provides a variety of Java APIs. Python is used here, and a C language wrapper is over for Java APIs. They are available. And to browse the files of HDFS instance, we have HTTP browser. So very easily we can work with HDFS. So the next technology, why we need another technology, Hadoop seems to be better. No, Hadoop started very well, but as our big data exponentially increase, Hadoop is not adequate. MapReduce is not adequate, right? So the birth of Spark, again from Apache. It is a unified open source computing engine. It supports Python, Java, Scala, and R. Scala is a programming language. And it runs anywhere from a laptop or a cluster of thousands of servers. So all same as Hadoop. See this point, it is 10 times on disk and 100 times on memory. So Spark promotes in-memory processing. So it is very useful or suitable for running iterative machine learning algorithms, widely used. How it evolved, you see, Mesos is a distributed framework. It was developed as a class project in UC Berkeley in 2009, and it is created by AMP Labs, which is now popularly known as Databricks, to test how this Mesos work. And later it was open sourced in 2010. It actually focuses on iterative machine learning programs and interactive queries and unifying real-time and batch processing. Actually, Hadoop was very useful for batch processing. But Spark is useful for both batch processing and real-time. We had in between Storm. Storm was useful for streaming real-time. But Spark is useful for both the applications, and most specifically, it supports applications where a part of it is batch processing and part of it involves stream processing. It can be very well done or handled by Spark. And it lives in GitHub, open source. It supports a wide range of data analytics tasks. So loading the data, streaming, and SQL queries, machine learning algorithms, Spark ML library is available. See, this unification is very important feature of Spark. Earlier to Spark, what the big data community was doing, they required to stitch the application out of multiple APIs and systems. Whereas Spark provides composable APIs. With this, you can build applications out of many smaller pieces from the existing libraries. So it is now easy to write your own analytics library on top of Spark. And it provides structured APIs like data frames, data sets, and SQL, which can be used by any application to develop something on top of it. And it is a very powerful platform for interactive as well as production applications because of its unification. So data scientists, they benefit from unified set of libraries of Spark like Python or R. It is useful for modeling the data, and web developers, they are also benefited using Node.js or Django, so Python based framework. So Apache Spark supports batch processing, interactive queries, and stream processing. Also, Spark can run over Hadoop, Mesos, or NoSQL. So this is the flexibility it offers. And it supports almost all persistent storage systems like when you take cloud, it supports Azure or Amazon's S3. It can run over HDFS. It can handle Apache's Cassandra. Cassandra is a key value store. It is coming under NoSQL. And it can handle Apache's Kafka. So, and it has its own streaming. Also, it has structured streaming, which supports both batch and real-time data. So, data already resides in a mix of storage systems, and it is very expensive to move data. But with the use of Spark, it can handle data available in Amazon, data available in HDFS seamlessly. Wherever data resides, it can handle. In Hadoop, it was not the case. Everything must be available in HDFS. But in Spark, wherever the data resides, it can handle it. And Spark makes the storage to look like everything is stored in one place. So the applications need not worry about the location of the data. So the difference between Hadoop and Spark. Hadoop has HDFS and MapReduce, which are closely integrated together. MapReduce works over HDFS. So you cannot write application that access data from somewhere else. Every data should be available in HDFS for MapReduce program to run. But Spark runs anywhere. It can run on Hadoop version 1 or version 2, that is Yarn, Apache's Mesos, or its own cluster, or in a public cloud. Anything is possible. That's why it's unified framework. And machine learning algorithms, they are iterative. As you know, with each iteration, the accuracy or the results will improve. So with every iteration, if you are writing the results in disk, then the latency comes down. So Spark solves this by having in-memory computation, by having an abstraction called RDD. RDD refers to resilient distributed data set. You can see here down, Hadoop's execution flow, you have everything on disk. So MR is map reduce, 1, 2, 3, some 4 tasks, everything, every intermediate results, they are on disk. But when you look at Spark's execution flow, because of this abstraction, RDD, it is possible to have computation both in memory and disk. So this is in memory, this is in disk, this is in memory with the various tasks. So we'll see more on that shortly. So Spark SQL, again, this is the ecosystem. Apache is Spark, has Spark SQL, Spark streaming, machine learning libraries, Spark MLlib, and GraphX for graph processing. So all these are available. Spark streaming, as I told you earlier, structured streaming is also available. So the components you can see, structured streaming, you can do advanced analytics, Python and R are available, lots of libraries. So we have low-level APIs like RDD, it's an abstraction, and the shared variables, distributed variables are available. On top of that, we have structured APIs, data sets, data frames, and SQL. The execution model is like this. In Hadoop, we had name node and data nodes. Here we have driver program and worker nodes. So driver program has a Spark context, and worker nodes, they are having different tasks and they have a cache on their own, and executor will run the tasks here. And these are managed with cluster manager. So the driver program is managing the worker nodes, and this will start the execution always. And it can be deployed in 2 modes. If it is a cluster mode, the driver will be inside the cluster, and if it is a client mode, the driver will be outside the cluster. And the cluster manager is equivalent to yarn in Hadoop. Driver program is equivalent to name node, and worker is equivalent to data node. So cluster manager is an external service to manage the resources like yarn. And this executor is a process which is launched in a worker node, and that runs the tasks allotted to a worker node, and it keeps the data in memory or disk storage. This is the important advantage of Spark. So either you can keep the data in memory, that is cache, or in disk storage. So the job consists of multiple tasks, and tasks are executed by the executors in worker nodes. And we have different stages. Stage is something like a temporary work or temporary file. So each job is divided into a number of tasks called the stage. And the stages depend on each other. And there is some flow in which these tasks need to be executed. Each stage has some input and output, and this output is stored in some staging file or database. Or sometimes, depending on the application, you may choose to store this in memory too. And Spark context, again, it creates a virtual environment in Spark, and it is very much required, or the most fundamental, I can say, in which all the necessary Spark configurations, they are all abstracted in one object. And Spark applications, they run as independent set of processes on the cluster, but they are coordinated by the Spark context object in the driver program. So when you start Spark, the Spark context is created, and that is responsible for unification. All the processes, independent set of processes, they are coordinated by the Spark context object. And the Spark context denotes the mode of deploying the execution of the submitted job. Also, the number of executors and memory required, everything. RDD is the basic abstraction available in Spark. So the elements which are partitioned across the cluster nodes, they can be which can be operated in parallel, right? They can be coordinated by RDD. So RDD is one abstraction. It offers three operations: map, filter, persist. So here I was showing you here. This RDD may belong to any pieces of application, like something say in application you want to apply some ML algorithm, or you want to sort out something, or you want to compare with something, you can use RDDs and seamlessly integrate. So this you can persist an RDD in memory so that it can be reused across the parallel operations. And also RDDs can automatically recover from node failures. You can also create your own RDDs, overriding the basic RDDs or system provided RDDs. You can create your own RDDs. So with this Spark context and RDDs, we are able to achieve this unification of Spark. And the second abstraction is the shared variable, which is used in the parallel operations. Whenever Spark runs a parallel function, a function comprising of number of tasks on different nodes. It has a copy of a variable used in the function to each task. Sometimes the variable needs to be shared across the tasks or between the task and the driver program. Either the variable can be a broadcast variable or an accumulator variable. Broadcast variable can be used to cache a value for all the nodes. In all the nodes, it's broadcasting. And accumulator can be used for some counter or some, you want to add up or you want to count. So Spark has you can see here the worker nodes coordinated by the cluster manager, and driver program is the initiator which creates a Spark context that can handle the tasks, the parallel tasks in different storage systems. And one more is either they can cache or they can store in the disk. So using an abstraction RDD, it is possible to weave the independent applications into one. So now Spark ML libraries are very popular for many applications. So Python libraries are also available, R libraries are available. So in lot of applications, Spark can be very effectively used. And its structured streaming is another important concept. So for several applications that involve both batch processing and real-time processing, Spark is the best option. Till here, any questions from the participants?
No, ma'am, none received as yet. You can please continue.
So who are using Spark? A lot of big companies. So I would like to receive some questions, maybe in chat box. You have a number of tools and technologies, but with the volume of data and with the challenges in the entire life cycle of managing this big data, the existing tools and techniques are still not adequate. That's what we feel. So you have to keep on revising the techniques. The tools are available. The techniques you need to revise so that the big data with all this, not only the size, so I told you a lot of dimensions are there. So depending on the application, whether it is IoT application or healthcare application or a natural language processing, NLP application, need to derive some useful information. That is the whole objective. So we have the concept of NoSQL for storage, aggregate models, different from the traditional relational database models. We have the concept of data lake, where we can store irrespective of the structure. We just keep on accumulating the data. So the file formats are very different, like Parquet format, Delta format. Lot of file formats are used to store the text data. And if the application involves images or audio or video, you can use data lake concept to create the repository, and based on the application you can do either batch processing, or most of the applications involving machine learning needs some real data processing. So that is also possible with these evolving tools. But we need to evolve techniques.
Ma'am, we have a question from Mr. G. Raja. He's asking how to calculate replication factor in Hadoop.
You don't have to calculate it. By default, it is 3. But based on the sensitivity, like if you are having here, say replica across the rack is costly. Replication across the nodes is less costlier. Replication inside a node, multiple copies in the same node, is not at all costlier. So based on the sensitivity, how your application requires, you have to use it. See, there is a trade-off. The more the number of replicas, high availability is there. But when you have a more number of replicas, write operation will be costly. So if your application is write intensive, very judiciously you have to select the replication factor. If the application is only search intensive or read intensive, then having more replications or more replicas is not a big problem. So it is only a trade-off.
Ma'am, there's another question from one Dr. Arunachalam. Is there any minimum RAM to run Spark?
16 GB is giving good performance.
Okay.
But the minimum 4 GB, 8 GB, see, it depends. Like you want to use for application like video summarization, or something like speaker identification or biometric identification. You need a GPU based server. So 16 GB RAM size may be minimum.
Thanks, ma'am. There's another question from Amreen Khan. What are the main benefits of Spark over MapReduce?
MapReduce offers Java, right, APIs. Nowadays, mostly MapReduce is not used because it is closely tied with HDFS. But Spark can run on anything, as I told you earlier. So Spark is preferable over Hadoop. MapReduce. Spark can run on HDFS. Spark can run on Amazon's S3 also. Whereas MapReduce is closely tied are integrated with HDFS. And with Spark, you can use Python libraries, R libraries, and you have unification concept, which is absent in Hadoop. Any other questions? I'm not able to see chat here. Okay.
No question as of now, ma'am. You may proceed.
I think with this, if there is no further question.
Ma'am, I have one question.
Yes, please.
Any cloud platform is available to practice Spark and Hadoop, madam?
Yes. Amazon's AWS.
AWS.
Yes, it's available.
Okay, madam. Thank you.
It's free also.
Okay, ma'am. In our system, it is burden for installing and we required minimum 8 GB RAM.
Spark installation is slightly tricky. You
Okay.
have to set up a cluster. With a single machine, it may not be very useful for solving most of the applications. You have to actually set up a cluster.
Yes,
Or
ma'am.
if you find that difficult, you can use the existing cluster in cloud. It's
Okay,
available
ma'am.
in Amazon.
Okay, ma'am. That's what I am asking.
Yeah.
Thank you, madam.
Okay, I thank the organizers for giving me this opportunity to introduce the big data technologies and to set up some background for this 5-day STTP. And
In case the
hope
participants have
these
any questions,
5 days will be very offering fruitful sessions to the participants. And I noticed a lot of hands-on sessions throughout all the 5 days, which will give a very good exposure, knowledge exposure to the participants. I thank Dr. Meenakshi and Dr. Golda for giving this opportunity to me. I thank all the participants and the organizers.
thank you so much, ma'am. It indeed was a wonderful session. As a token of gratitude from us, I would like to present the digital certificate to you, ma'am.
Thank you.
Just a second, ma'am. Yeah. This is a small token of appreciation from our end, ma'am. We'll be mailing this to you shortly. Thank you so much for your enriching session. In case participants do not have any questions, can I request you all to kindly just unmute your video so that we can click a grip picture. I'll also request Dr. Kanchana to unmute her video. Thank you so much, ma'am. Thank you. I hand over to Deepa for the further announcement. Thank you, Dr. Kanchana, for taking your time out and sparing it for us to deliver such a wonderful talk on Hadoop and Spark and other platforms which are there for big data analytics. I'm sure as you have set the stage for the rest of the sessions, we have sessions on Python, on R, and which we will also be dealing with a session in sparkling water, which is a very new technology which will be done by the resource person from Walmart. So you have set the stage so right for the rest of the STTP. I thank you on behalf of Department of CSE for taking your time out and enriching and enlightening us with your talk. Thank you so much.
Thank you. Thank you. Thank you.
And that was a wonderful session, ma'am. If the participant does not have any queries, do you have queries? Okay, fine. So, dear participants, you can look for the feedback link in the chat, and the form will be open only for 10 minutes. And based on the feedback fill, the attendance will be provided. And afternoon session will be a hands-on session using Python on NumPy, Panda, and Skyline at 2 p.m. I request all the participants to join the session, afternoon session sharp 2.